Hello, today we're going to look at amounts and volumes of gases for this higher tier video for GCSE Chemistry. Now, the first thing to remember is that the volume of 1 mole of any gas at room temperature and pressure occupies 24 decimeters cubed. By room temperature and pressure, we mean 20 degrees and 1 atmosphere of pressure. So imagine we had a gas in a container and the temperature is 20 degrees, we call that room temperature, and it's at 1 atmosphere of pressure. That's basically the pressure at sea level. Sometimes we refer to that as room temperature and pressure, or standard room temperature and pressure. What we would notice that if we had 1 mole of the gas, that would occupy 24 decimeters cubed. Now, 1 mole, as you may remember from a previous video, is the Avogadro's number, or Avogadro's constant, and you may also remember that that number is 6.02 times 10 to the 23. That's a lot, it's a high number, but that's the number of particles in 1 mole of any substance, including gases. So that means we could look at a second gas, and if we have the same conditions, i.e. 20 degrees and 1 atmosphere of pressure, we are also going to have 24 decimeters cubed that gas is going to occupy. Remember, decimeters cubed is a volume. So 1 mole of another gas will occupy the same amount of volume, which is 24 decimeters cubed. We can just make a note of that. 24 decimeters cubed. Okay, so this is the key thing that we need to remember, this sentence here, and we're going to use that to work out various calculations, or do various calculations for the chemistry course. But what's going to be really useful is if we remember from previous videos and from this video the following two equations. So if we want to work out the volume of a gas, it's simply the number of moles of the gas multiplied by 24. That's 24 decimeters cubed. And we can work out number of moles by rearranging that equation, but we can also work out number of moles by what we've looked at previously, which is mass divided by relative atomic mass, or mass divided by relative formula mass. And these two are going to be really useful for the calculations that we're doing in this video today. So it might be worth you making a note of those while I just highlight them as being very important. And in fact, why not give them a little color while you're sitting there making a note. So there we go. Now we can use that information to do calculations such as this one here. So what is the mass of 1.8 decimeters cubed of nitrogen gas, N2, measured at room temperature and pressure, and the relative atomic mass of nitrogen is 14. You might want to give that a go now, and if you do that and get the right answer, you may not need to watch this video. But for the remainder of the video, we're going to start off quite simply and work our way up to a question like this one, and one that's actually slightly more tricky than this one. Okay, so starting off nice and simple, we've got the sentence from before: the volume of 1 mole of any gas occupies 24 decimeters cubed. So 1 mole of oxygen will occupy 24 decimeters cubed at room temperature and pressure. If we had 2 moles of oxygen, that would occupy twice the amount of volume, so that would be 48 decimeters cubed. And that is hopefully quite straightforward. What that means is that if we have the number of moles, if you can calculate the number of moles, you can calculate the volume of a gas. If you know the volume of a gas, you can calculate the number of moles. And that's basically linked to the equation we looked at on the last page, and we can make a little formula triangle. If you're not confident with your maths, or if you're not confident in rearranging equations, we can use a formula triangle. We can use a formula triangle like this to do the calculations described by the writing in red there. Okay, so let's look at the next set of questions. You can pause here and give these a go if you like, but if not, let's go through them together. So we're trying to work out moles for the first two, and we've got 48 decimeters cubed of our carbon dioxide gas. Now you could just simply say, well, 1 mole occupies 24, and 48 is just 2 times 24, so that's going to be 2 moles. But when we've got a number like 1.2, now your maths might be good enough to do that, to work out that from a ratio perspective, but we might also just use our formula triangle just to keep things nice and easy. So there's our formula triangle that we learned on the previous slide, and we can use that. So we're trying to work out the number of moles. So that's just volume divided by 24. So our volume is 1.2 decimeters cubed as given in the question. We divide that by 24 and we get an answer of 0.05 moles. There's our first two answers, working out moles. In the third question, we've actually got a mass of methane and we want to work out the volume that mass of methane occupies. Now we can't use our formula triangle here because we don't know the number of moles and we don't know the volume. So we have to use the other equation that we had on the previous slide that we've come across before in previous videos as well. And that's working out the number of moles as mass over relative atomic mass. And we want to work out the relative atomic mass of methane. We've done lots of practice on that, so I won't make you do it again. We can just remember, or I'll just tell you that it's 16. So we can do the number of moles as 64 grams, which is the mass, divided by the relative formula mass, which is 16. And 64 over 16 gives us 4. That's 4 moles. And if we know the number of moles, it's quite straightforward from this formula triangle to work out the volume that 4 moles of methane occupies. That would be just a case of 4 times 24, which would then be 96 decimeters cubed of methane gas. Okay, so that's our third answer. In terms of the last question here, then this is the one that we had on the very first slide, and we're trying to work out a mass of 1.8 decimeters cubed of nitrogen gas measured at room temperature and pressure, and we're given the atomic mass of nitrogen. So we want to work out the mass of 1.8 decimeters cubed, and we can use our formula triangle here because we've got a starting volume of our nitrogen gas, so we can work out the number of moles. And that's just simply volume over 24. So that would be 1.8 decimeters cubed divided by 24. And that gives us the number of moles. That would be 0.075 moles. Now, if we know the moles and we know the relative atomic mass, we can work out the mass of our nitrogen gas. So we use our second equation here. Moles is mass divided by the relative atomic mass of nitrogen. We know the number of moles, which is 0.075. So we would do 0.075 equals the mass, which we don't know yet, divided by the atomic mass of nitrogen. Now nitrogen is N2, as we can see there. So we need 2 times 14, which is 28. If we rearrange the equation, it's a case of 0.075 times 28 to get the mass. And that gives us a mass of 2.1 grams, and that's our final answer for that question there. And we use 2 equations to calculate the answer. Now, just to finish this off for this video, we've got a slightly tricky question. This requires what we've learned in this video plus what we've learned in our previous videos on reacting masses or reacting amounts. So give this a go, see what you think. If not, I'll go through it with you now. So we're trying to work out the volume of chlorine, which reacts completely with 1.84 grams of sodium. So how would we actually do this? Well, we need the number of moles of chlorine if we're going to work out the volume of chlorine. And from our equation, we know that 2 moles of sodium react with 1 mole of chlorine, but we actually haven't got 2 moles of sodium. We need to work out the number of moles of sodium, and we can do that by working out the mass divided by the relative atomic mass. So it's 1.84, and then the atomic mass of sodium is 23. And if we work that out, that gives us an answer of 0.08. But we know from the equation that 2 moles react with 1 mole of chlorine, so it's in a ratio of 2 to 1. So if our sodium is 0.08 moles, that means our chlorine is going to be half of that, because it's a 2 to 1 ratio. It's going to be 0.04 moles of chlorine. Now, hopefully the rest of it should be straightforward. The volume of chlorine is going to be the number of moles times by 24. This is our equation that we learned on this video. So that would be 0.04 times 24, and that would give us an answer of 0.96 decimeters cubed. Okay, so some tricky stuff in this video, but hopefully you got the hang of it. Those 2 equations on that sheet are going to be very useful, and sometimes you need to combine that with other equations, for example with reacting masses, but hopefully this has given you some idea how to do it. Thank you for watching, and I'll see you again soon.